Hi, this is Greg Gremke. This is part two of a presentation on the economics of energy policy. I work with economic thinking, and this is from presentations given at camps during the summer and during the fall at workshops. Energy is just such an exciting topic. There's so much going on. And I'm going to argue that there's an energy race going on. So this overhead's looking at energy production, an overview of U.S. energy sources and policies. So if you run down the line, we've got hydroelectric power, nuclear power, coal power plants, natural gas combined cycle plants, the more efficient natural gas plants, wind power, both onshore and proposed offshore wind power operations. You've got solar on homes, you've got solar, just out in fields, and then you've got molten salt plants where all the mirrors are pushing solar toward a central tower of salt and heats it up, superheats, so it can continue generating heat after sunset. This is all the mirrors are like pointing toward the solar thing in the middle. Then, yeah, solar installations, commercial, residential. And then you've got a whole range of other energy policies, biofuels, wood pellets, ethanol. You've got in-stream hydro, where you put the hydro thing in the stream. So again, this is just part of energy policy, but this is sort of the industrial, mostly industrial energy production overview, and also for utilities that produce power for businesses and homes. So the general economic view sort of is all these technologies have engineering, hundreds, thousands, millions of hours of engineering development over decades behind it. There are technology advantages with each one. There's science and what's the maximum amount of energy you can get from the sun? Well, you can't get more than is actually in the sun's rays. Or what's the maximum you can get from wind blowing or water falling? Each of these things has advantages and disadvantages, and it's a moving operation as engineers, enterprises, entrepreneurs, innovators, research scientists are trying to push the capabilities of each of these technologies forward to make it more efficient, to make it safer, to make it less costly, more valuable, more flexible, more reliable. So it's an ongoing race, and there's no way to know who's going to be the winner. We can try and figure out who's ahead now in different technologies. This is a post was made in the Ethos debate site, sort of a quick overview of a book called Smaller, Faster, Lighter, Denser, Cheaper by Robert Bryce, who has the next updated or new book just released in the last few weeks. But the argument is we're looking for technologies, whether they're material science, the materials that we make cars and rocket ships out of, or whether they're energy sources like nuclear or wind or solar or oil. Each of these we look for ways to make it energy dense so that there's more energy comes from a smaller size. Automobiles, for example. With the gas engine, each new generation of auto engines tends to be more efficient, tends to get more better mileage, less polluting, because pollution is a form of waste. Any unburned hydrocarbon that comes out of the back tailpipe of a car is, engineers hate that, because if they could burn that, they could turn it into more power. So materials and designs allow them. I have a little Volkswagen Jetta with a 1.4 liter engine, which is really tiny by the standards of cars over the years, and it's got a turbocharger, so it's getting 40 miles per gallon. It's very peppy, but so a fast car, in the Jetta world, energy efficient. And the Jettas that I had, 6-7 years ago were heavier cars, got 21, 22 miles per gallon. So tremendous advances in technology. Is sort of what you're looking for. How do we make it smaller, faster, lighter, denser, cheaper? And the challenge with all the renewables, solar and wind, is that they lack the energy density that comes from fossil fuels. They also don't pollute the way that most fossil fuels do. So there's trade-offs there. So can you make fossil fuels less polluting and keep the energy density and be cost competitive? Or can you make solar and wind somehow more energy dense and reliable? Those are the challenges going on in competition. So again, it's an energy race. The energy industry, it's you can describe what's going on, but it's also dynamic. If we did a whole course of hours and hours looking at each of those different energy production technologies, we'd find a whole bunch of innovations in the works, roadmap to the future. You could look at the past, we'd see how much things have advanced. But again, it's a snapshot, and these are dynamic. They're adopting new technologies, new materials. You could say it's an animation. A better would be an animation of energy production, where you saw this progress over time, increasing efficiency, reliability, trying to reduce pollution, etc. So again, dynamic, innovative, entrepreneurial. Which companies are sort of doing what they've done for decades, and which ones are trying to do new things, make things a little bit faster, a little bit cheaper. A lot of this turns on computer power. Nuclear energy, for example, our whole nuclear energy industry was developed before there were computers, right? These are mechanical systems. They're safe compared to other technologies, but with computers, maybe we can make them much smaller, much cheaper. All the effort in fusion over decades was without high technology from computers. Now there's fusion operations trying to make it smaller and using advanced technologies of various kinds. Magnetics have improved. So again, we have this ongoing race, dozens of different technologies charging ahead, trying to compete. And this is the story that Robert Bryce is telling in his book. Another book, U.S. Energy Policy and the Pursuit of Failure. This is one I'd also recommend, and I'll talk about this probably in another presentation, but the challenge is trying to choose the winning energy. This begins with a story about how Congress chose to fund fusion, 20 years ago, because they thought it was the solution, but turns out fusion was far further off than they'd hoped, and no amount of money could make fusion work in the time frame that they had. So the economic principles for energy, again, as I've talked about before, you've got scarcity, you've got limited resources, limited land, capital, labor. Energy density, how much energy you get for the land and wind and solar versus natural gas and nuclear. There's the issue of reliability and security. How secure is the energy installation? How reliable is it? You've got fixed cost and marginal cost. So for wind and solar, they've got high fixed costs for installation, but they've got very small marginal costs. I mean, there's maintenance in the winter. Wind power in Minnesota, the ice will slow things down, or dust and dirt will get on solar, but they're not paying for the fuel the way that oil, coal, nuclear, and natural gas do. Each of these technologies, you've got knowledge and incentive challenges that have to do with the nature of the industry, whether it's centrally subsidized or state subsidized. And critics of fossil fuels say they're subsidized in a big way. Critics of wind and solar say they subsidized. Nuclear, the argument has been subsidized forever. But each of these is also highly regulated as well as subsidized in different ways. So you try and figure out how big are the subsidies, how are the regulations necessary for safety, or are they for some other reason? So each of these things are areas that debaters can research. So what are the energy regulations? The argument is that, again, special interests tend to capture the regulatory apparatus and favor one kind of energy over another. So isit.org, which is the education side of Free to Choose TV. If you go to Vimeo/isit, you can find their Power to the Planet video, and this is a 15 or 18-minute video that is an overview of oil, gas, solar, coal, wind, nuclear, looking at the advantages and disadvantages of each. It seems to have sort of a pro-nuclear cast to it, but it's hard for me to tell. But it's descriptive, it's scholarly, and it's a valuable sort of background to different kinds of energy. And then they've got Energy Solutions, Who Chooses, which is another video. And this is a critique or criticism of government energy policies which historically have been misguided. We hear of stories like Solandra during the Obama administration that got this huge funding ahead of the second election for President Obama to try and create jobs, lots of solar energy jobs when the economy was still growing very slowly. It turned out to be a disaster, bankrupted the company, cost taxpayers hundreds of millions of dollars. Now, maybe that's cherry picking, a bad example. Maybe other government subsidies of different kinds of energies have been productive, have been pushed innovation. Those are issues for debaters to research. But this looks at a couple energy proposals. One, the German switch to renewable energies, wind and solar, which led to some unintended consequences that increased pollution and emissions and raised costs dramatically. And then in the United States, the government chooses to subsidize ethanol as well as other biofuels. And that leads to significantly increased costs for all taxpayers and all people driving cars, as gas is less energy intense. And the energy that the government didn't subsidize, in fact couldn't stop, was the hydraulic fracturing, the natural gas deep underground. And so it tells the story of a farmer, some farmers that are in the ethanol business, but other farmers that are just farming in Pennsylvania, but they're making lots of money by allowing natural gas to be pumped out beneath their lands. And so is that safe? Does it make sense? But the government favoring some energies, generally against others. These are some examples. And I think, again, you could say, well, gosh, these aren't representative. There's other examples. Great. And you could research those too and read more about it. But these are at least a good, again, an introduction, and eliminating ethanol subsidies, renewable fuel portfolio, those sorts of things. Pretty strong affirmative, because even environmentalists are against ethanol now. It was the sort of the nationalists wanted ethanol so they wouldn't have to import oil as much from Venezuela or Saudi Arabia. And the environmentalists thought it would reduce pollution and be renewable because the corn absorbs CO2 before it's released. But as they do more research, we've got plenty of oil and natural gas, and ethanol production uses more energy than it produces, it turns out. So, recommended resources, videos. So here's an article on, this is another interesting thing. If you're looking at things that are critical of wind energy or solar energy, you could cite, fossil fuel sources or research groups, but often you can find the solar energy critical of the wind energy industry and the wind energy industry critical of solar. Both of them rely on subsidies by the federal government and states governments of various kinds. And the argument is this was needed to get them started. But now they say, gosh, the prices are dropping dramatically. We should be able to do it without subsidies. But that's another area to research. So maybe the best thing is to try and end all the subsidies. Fossil fuel subsidies, wind, solar, whatever subsidies you can find, phase those out. That way you've got a balanced affirmative and say, look, the energy industry will sort itself out without subsidies. And you don't have to be pro-fossil fuel or pro-renewable. You can just be against subsidies. So this is about the wind energy saying, look, if you extend subsidies for solar, that's going to damage the wind industry. And this is a fall 2019. This is on the, so the point in this overhead is to look at sort of other technologies. So wind energy and solar energy, we've got a lot of money going into those, a lot of people excited about it, but maybe the best wind energy isn't going to be windmills on land and in the sea. Maybe it's going to be up in the sky. So Google was funding a giant sort of kite that could generate wind up in the air, and they would anchor these things and it would float around. And now Google recently cut its funding for this particular project in the last, I think in March. So their project didn't work, but it was an experiment and an effort. There are some other companies still trying to generate kite energy because the wind is so much steadier and so much faster up in the air. And you don't have to have these giant concrete things holding things down if you've got propellers generating energy in the sky. Again, who knows if it's a good idea? You want companies to research these alternatives. So, federal energy policy background on the overall topic. We've talked so far in this section about different kinds of energy production. But again, there's also energy distribution, which is the grid or the rail lines or the trucking, shipping, the Jones Act, which restricts shipping energy like from Alaska to Hawaii or between any U.S. ports from the U.S. energy installations. They can't ship energy to Puerto Rico because of the Jones Act. So you could say we should eliminate the Jones Act, which would allow for more efficient transportation of energy along America's ports into our territories like Hawaii and Puerto Rico. Then you've got energy consumption issues. Again, the regulations on toasters, washing machines, other things to try and be more energy efficient. Supposedly this saves taxpayers or the consumers money because their washing machine uses less energy, less water, but it also takes a lot longer and doesn't clean as well. So you've got trade-offs on all these sorts of things. And should the federal government be deciding how much, what sort of miles your car could get, or how much energy your washing machine should use. So the question is, what's the role of government in this? And then, what's the role of the federal government? Maybe you want energy federalism. So where the state policies decide these energy issues. That's closer to the voters. And again, energy is different in different parts of the country. We've got lots of hydropower here in Washington State. They don't have much in Arizona, but they've got a lot more solar. So let them make the energy policies for their states. We've also got the issue of energy monopolies. This has to do with regulated utilities that monopolize the power of electricity or natural gas in a particular region. And you could call for more competition, let more energy companies start up and flourish and try and provide sources or microgrids that provide different kinds of energy in smaller communities. And then the issue of energy externalities, which are pollution and other issues that costs that fall outside the consumption, the production and the consumption of the energy, like pollution. Okay, I think I'll stop here and I'll set the overheads up so you can follow any of the links that are here and find some of those videos and so forth. Thank you.